All right, so in this video, we're going to talk about piecewise functions. We can label this 5.2a, and we are going to briefly talk about graphing, but not too much, so you probably don't need to worry about using graph paper for these notes. All right, so first of all, what is a piecewise function? So it's kind of in the definition. It is a function made up by pieces. So it's defined by two or more functions. And you can see a picture of a graph of one right here, which you're going to sketch into your notes. Notice that I just have two different pieces here. These are not part of the same line. I have a line that's on this side and a line that's on that side. They don't have to be lines. You could have curved functions. So sometimes piecewise have other curves that happen over here, or maybe they have a solitary point. It's just lots of different pieces on one graph. All right, so each equation applies to a different part of the domain. Let's pick the correct thing to write with, domain. And you can see in this example that we have two different equations here. And so while we're learning about these, one thing we want to note is that these are our equations or our functions on the left, and then on the right, these are the given domains. So we see here that we're going to have two different pieces. So if we look at our graph just to see how this matches, the first piece happens when x is less than or equal to 0. So x is 0. If I mark that on our graph, x is 0 right here, right? And I'm saying that this is happening when x is less than that. So if I look on the left side, that's this part of the graph. And we can see that in this space, I started at 1, and I have a slope of 2, except I'm going backwards, so I've got this graph to the left-hand side. If I look at the other piece, so the other piece is going to be happening when x is greater than 0, so that's going to be on the right-hand side. And that's going to be this line, x plus 3. Notice that because this says greater than 0, I'm going to have an open circle, and I'm going to go to the right. So a few quick things to note. These functions, I kind of sketched them out just a second ago, but these functions can never overlap because they are by definition a function, which means each input has one output. It has to pass the vertical line test, right? Nowhere can I draw a vertical line and it hit twice. That also means that we will always see open and then closed, or open and open. We cannot have closed and closed right on top of one another, because they must pass the definition of a function. All right, so you may want to add that up there at the top of your notes, just the vertical line test, and remember that each input has to have one output. All right, so let's look at a few examples of how we read these. All right, so this is actually giving us 3 examples at once. So if it were me and I were taking notes, I would section my paper off and do F, G, and H. So we'll first do questions 1 and 2 just regarding function f. So questions 1 and 2. So we're always going to start by looking at our domain first. So I notice that my domain is split into 2 pieces. I have parts where x is greater than 3, or less than 3, and parts where x is greater than or equal to 3. So the first thing we have to do is decide, is this input that I have been given, is that in the top or the bottom domain? So 5 is going to be greater than or equal to 3, which means 5 is going to belong to the bottom function. If we look at this other value, the other one is going to be at -9. So look, notice I'm doing 1 and 2 at the same time. -9 is less than 3. So -9 is going to be part of the top function for question F. All right, so now that I've decided that this is in the bottom function, I'm going to evaluate it in this equation. So I'm going to evaluate 5 plus 7, and that's going to give me 12 as the output value. All right, so if I were to do the same thing for 9 I realized was in the top function. So for 9, I'm going to do 4 times -9 minus 1, which is going to give me -36 minus 1, which is -37. I don't know why my stylus is struggling so much. All right, so the output at 9 is -37. The output at 5 is 12. If you need to pause and rewatch that example before you move on, please do so. All right, these next 2 examples, we're going to look at G. And I said 2, I meant 3. All right, we're going to look at G for G of -6, G of -2, and G of 4. So now I'm using this G equation in the middle. All right, so I noticed this one also has two pieces. Again, it doesn't have to have two, but this one does. And I'm going to identify the domain. So I see one of them is x is less than or equal to -2, and the other one is x is greater than -2. So I'm going to look at my different functions here and see if I can figure out which section this belongs to, which domain. So -6 is less than or equal to -2, so this is going to belong to the top equation. 4 is going to be greater than -2, so that's going to belong to the bottom equation. And then you may have a question about -2 here. Well, where does that belong? So notice that one of them is less than or equal to -2. The other is just greater than -2. So this one will actually belong to the top equation. All right, so now I'm just going to evaluate in all of those three places. So -6 in the top equation is going to be 3 halves times -6 minus 7. And we can use a calculator to get that output if we need to. -18 divided by 2 is -9. So this is -16, I think. All right, -2 also belonging to the top equation, so I'm going to evaluate it in the same function. -2 minus 7, that's going to be -3 minus 7, which is -10. And then lastly, I'm going to evaluate 4. This one's in the bottom equation, so 11 minus 2 times 4 equals 3. All right, remember, when I'm evaluating, I think this is just as a reminder, when I'm evaluating, I'm substituting into these x variables. So that's how I know where I'm putting parentheses and where the value is going. All right, so let's look at our last example, this example for h. All right, so the only thing that makes h different, there's kind of two things. One is that I notice this has 3 domains. So I've got a top domain where x is less than -1. I have a middle domain where x is between -1 and 4. And then I have a bottom domain where x is greater than 4. So the first thing, again, that I'm going to do on all of these is evaluate where they are. So I see down here I have x equals like an input value of -1. Remember, this is going to be equal to -1, so this is actually going to go in the middle domain. All right, question 7 is going to have me evaluate -7, which I know is less than -1. That's going to go in the top domain. And then lastly, I have h is 6. This is going to go in the bottom domain. All right, so we're just going to take turns evaluating in each of those. This number 6 right here is probably, this is the reason I kept this example and didn't just end the video already, is that if I go to plug -1 in this middle equation and the function is just 3, notice there's nowhere to put an x. That means the output value is 3 no matter what you plug in. So there is no way to substitute a value. The answer is just 3. And I would make sure you understand that. All right, question 7. I'm going to evaluate into the top equation. So I'm going to do -7 plus 2. Notice that I'm paying careful attention about the negative that's in the front of that equation, in front of the x, and using parentheses appropriately. This is going to give me an output value of 9. And then lastly, we're going to evaluate the bottom function at 6. I don't know why I said 4. Plus, geez Louise. Let's try reading, shall we? Minus 8, so that's 30 minus 8, which will give me 22. All right, so make sure that you have all that written in your notes. We're going to work more on evaluating and just a very little bit about graphing and kind of picking equations, matching them, because that's kind of a more complex skill. But make sure you have these notes and you are ready for class tomorrow.